Hello everybody, welcome you to a session of clustering Asterisk with Kamailio. Let me first introduce myself a little bit. Klaus Darilion, I'm working for a small company in Austria called IPcom. We do lots of voice over IP, security audits and consulting, mainly for Kamailio. Last time it is really getting popular to use Kamailio as a load balancer in front of Asterisk servers. For high availability or just to improve the performance of the cluster. So I'm actually coming from the Kamailio side of voice over IP, so open source zip proxy. But as you know, like there's lots of other software also in this area, like Asterisk, and more or less you end up using all of this software. So that's why we meanwhile give consulting for all of the typical voice over IP softwares. I thought it will be a start with like probably how many voice over IP providers started when they started to use voice over IP. They somewhere installed an Asterisk server. Of course, it was at this time the newest version available, and they had like a few customers, so it was just one server. Probably they had an identical server somewhere sitting around as backup. In the beginning, it was mostly like no automatic failover, but in the beginning, it was sufficient. So, of course, then maybe after 2 years later, it was getting more and more complex, the whole thing. So, the hardware was getting old, and the provider wants to switch to a new hardware, to a new server, but probably without minimum service interruption. Also, the Asterisk software was rather old, and there are several reasons to update the software. For example, you want to fix security issues. And then another thing is also you want to use, for example, the new features coming with the new versions. But maybe it may also happen that you have customers which have very fancy AGI scripts or AMI scripts, and there are some changes in maybe also in the dial plan, how, for example, the invalid extension is handled, or the change from macros like the goto and goSoup was changed, how the macros behave. So, and it's not easy, it's not always that easy to just switch to a new version, because you have like dial plans and application which behave on the old behavior. And probably, or hopefully also your customer base was increasing, so you might run into performance problems, and the more customers you have, of course, it's always getting more important to really have a high available system. And I guess that's what it looks like with many providers after some time. You have different kind of Asterisk versions available and different customers using different servers. So most of the providers, of the customers have a different configuration. They have to configure a different IP address for the Asterisk server. And it's really getting complex to manage all this stuff. So, and what I propose is here, you need a load balancer. Because with a load balancer, you can really ease the management of such an Asterisk cluster. So the first thing is where to get a load balancer. For sure, you can buy a commercial one. You go to Acme or to F5 and buy the big IP. Of course, they're very powerful, but they're also very expensive. And as you're already used to open source, you're using Linux, you're using Asterisk. So why not using an open source zip proxy? For example, Kamailio. So what is Kamailio? First, it is pronounced Kamailio, not as many do like Kamailio or something like that. It's actually a Hawaiian word and meaning having a conversation. So it's called Kamailio. And it's not only a load balancer, it's really a powerful zip proxy. It's a if you take a look at the zip RFC, it defines 3 components of a zip, like a server component, like registrar functionality, redirect server, and proxy. And of course, all these parts can be done with Kamailio. We had 10 years. We celebrated 10 years of Kamailio quite recently, and probably the name Kamailio is not that new. It's like 2 years now, but there were lots of name changes. There were like forks. It began 10 years ago in Germany at the Focus in Berlin with the name SIR, Zip Express Router. Then there was a fork called OpenSIR. Then it was renamed to Kamailio because of trademark issues. And then the original SIR and the Kamailio guys like teamed up again and made like one product again. And the software project is called Zip Router now. And the release, which is is still called Kamailio. So the zip router is really just the software, and Kamailio is like if you take a look at Linux and Red Hat. So it's the software, it's zip router, and the distribution is called Kamailio, where you also get the management tools and so on. Kamailio has a rather simple core. That means it's just more or less the transport layer and the message passer. And all the features, it's rather similar with Asterisk. All the features are implemented using modules. So meanwhile, there are more than 100 modules. There are, for example, modules like database driver or radios access. And of course, there are modules just for functionality like NAT reversal, registration handling, message manipulation. This is really powerful within Asterisk. Access to memcache daemon, doing load balancing, presence functionality. So there are really lots of features now in Kamailio. So, of course, of these features, what can we do with Kamailio? In this case, I show you mainly the usage as load balancing. But once you put a Kamailio as load balancer in front of your Asterisk, you even have the options to do more in it. For example, NAT keep alive. Usually, you're using Asterisk, sending options request to your customers to keep the NAT pinhole open. If you have like 1,000 customers on an Asterisk servers, you really have a lot of load with the options and like a lot of retransmissions and so on. So it's also probably a smart idea to move, like for example, the NAT reversal feature, keeping the sessions alive also on the load balancer. There are lots of features available in Kamailio to do this, either also using options request or just lightweight carriage return line feed for keep alive. You can also, if you want, depends on the configuration now in detail. Like if it's like more or less a POTS replacement service, then it's also quite easy to move all the registrations from Asterisk to the zip proxy, to Kamailio. If it's a PBX service where you always need to know exactly if now a client is registered or what's the current state of the call, then it's usually better to have the registration still on the Asterisk. One interesting thing is also you can apply security policies. That means you can do, for example, rate limiting to find out if somebody wants to DDoS you, or just authentication. For example, you can turn off the authentication in Asterisk and do the whole authentication on the load balancer. So that's always like there is no single rule where I can say, okay, always do the authentication on the zip proxy. It just depends on actually what your setup is. And of course, you could use it for protocol conversion. That's nowadays not more so important because Asterisk now also supports TCP and TLS, but like 2 years ago, it was very often used just for protocol conversion. So now I want to show you a few use cases, what you can do, for example, with Kamailio as a load balancer. And then I'll show you some examples. So I don't show you examples of all the use cases because that would take 2 or 3 hours. So, but one very useful thing is now that you have a single ingress point into your zip network. So you don't have to tell every customer a different IP address depending on what kind of Asterisk server he's using, or you just give them the IP address of the load balancer, and then at the load balancer you have some algorithm where you decide, okay, which user will be hosted on which Asterisk server. So that really eases configuration at customer side. Everybody uses the same IP address or the same domain. It also eases configuration of your firewalls, but because you have only one ingress point anymore, where you apply all the firewall rules. Second example is, of course, you want to distribute the load to Asterisk, to identical servers. So there are lots of different algorithms how you can share the load to several servers. One also interesting feature is what I, for example, often use is that you can use for certain users, certain server. You know, for example, there's a user which has a really old AGI script which needs an old Asterisk version. Then you just configure your Kamailio that only this single user gets routed to a really old Asterisk version, and all the others are getting routed to the new Asterisk version. So there are lots of different algorithms available what you can do in Kamailio. So rather also very expensive is like this, the features I showed you before were like really if everything is running fine in your network, just distribute the load. But what happens if there are some crashes of your servers? Like the request is forwarded to a server, and now the server crashes, maybe because of this request, or just is something going on this server. So, and you can configure a failover routing in Kamailio. That means, for example, if there is no response within a certain time, maybe 2 or 3 seconds, you just forward the request to another Asterisk server. The nice thing would also be like if the Asterisk server, the first one, is not crashed, but just like heavily loaded or seems to lock up for a few seconds, and then it processes the invite later, then maybe we have like the call created 2 times on the 2 different Asterisk servers. So, but Kamailio takes care of this. If it forwards the request to another server, and like after 1 second gets back like a 180 ringing from the old server, from the first try, it cancels the request, the first one. So Kamailio is quite smart. Or you can also be, for example, configure that it should also do a failover on certain response codes. Probably it should not do a failover on user busy, because also if you use another Asterisk server, the called user is still busy. But for example, it's like internal server error or something like that. You can also configure a failover, and you can do this as often as you have servers available. And of course, if all servers would not work anymore, then you send back a failure code to the caller. Of course, it's also smart to skip broken servers. So if you already know that like server 1 and server 2 are broken, there's no benefit in trying it again and again. So then you just forward the request only to the servers you know which are currently working. And for this, we need to know which servers are alive and which are not alive. So there's a probing mechanism in Kamailio where you can define that all the potential targets where you forward a request are always probed if they're alive. So you're sending options request, and you can configure on how long the server, within how many seconds the server has to respond. And after like 3 failed options requests, you mark the server as broken, and then you don't use it anymore. But you still probe it, and if it comes back, it automatically will be used again. And you can also configure if you can do it with the options request, with a faked invite request, with the info request, and if certain response causes are should be taken, like, okay, 200 OK is quite easy, okay, the server is alive, but what if it sends back 404? Does this mean the server is broken, or does it, because with Asterisk, usually if you send the options request without a username, you get back a 404, so you can define 404 is also a good response code, not a bad one. A very interesting feature is you can change the configuration of the load balancer without restarting the load balancer. For example, currently all the traffic is distributed to over 2 Asterisk servers, and then you add a third one. Then the traffic gets distributed to all the 3 Asterisk servers, and if you remove one, then automatically the traffic is only distributed on the existing 2 servers. And that's very smart, for example, also if you want to replace a server with a new hardware, you just put in the new hardware, install it, then you activate the cluster to use the third server, and if everything is fine, then you just replace the first one. And this is all possible without service interruption. Probably you don't shut down the server and then you reconfigure Kamailio. You first reconfigure Kamailio, then you wait like 2 or 3 hours that there are no more calls on the old server, and then you remove it from the cluster. And this one is also quite popular. Like you want to test a new Asterisk version. Probably you install it somewhere and test it really, but you update your production machines, and then something is buggy with the new version, or it somehow behavior changed. So you add the new server with the new, for example, with the new Asterisk version. Of course, as long as you don't tell Kamailio, it won't be used. But for example, you change the Kamailio configuration and tell him, okay, this, like only a certain user should now use this new server. You know you have friendly customers which are always eager to test new features or new versions. Then you or which are capable of giving you proper feedback if something is wrong. So then you configure Asterisk to just use this single customer to the Asterisk server. Yeah, and what if it doesn't work? No, you just reconfigure Asterisk to the old configuration, and then all the traffic is routed again to the old Asterisk versions. So those are features you can all implement with Kamailio as load balancer. So now I had picked up 2 of these features and show you how you can really do it with Kamailio. First of all, I want to know who ever used Kamailio in this room? Okay, that's not a lot. So I will show you a little bit how configuration of Kamailio works. You have a configuration file called kamailio.cfg, and there you configure more or less the handling of the messages. So you can define it for every message. Like you have a certain root block where you define how requests are processed. Then you have a reply root block where you can define how replies are processed, and you can also like add header, remove headers. And you have a failure route where you handle requests where the forwarding failed. Like you get a failure response back or don't even any response. And there are some more root blocks, but these are the most important ones. And inside these root blocks you use like, it's a mixture of a shell scripting language. It looks from the syntax, it looks similar to C, but of course it's not that powerful. It's a mixture of a shell script and a C syntax language where you have like functions to do something, or you can have variables to store values, you can make simple calculations, bit operations. So it's still quite powerful. So if we just take a look at load balancing now, you have 2 options within Kamailio. The first one, there is a dedicated module for it. It's called dispatcher module. And the balancing is done on various algorithms. I'll show you later which algorithms are available. And usually you do the balancing based on some data available from the incoming SIP request. For example, based on the from user ID, or for example, based on the call ID, or if you use multiple domains, just for example, based on the domain, so that all users, for example, belonging to a same domain or to a same hosted PBX will end up on the same Asterisk server. And the second option you have is really to do the load balancing manually. There are the scripting language in Kamailio is very powerful, so you can really implement all yourself. You can make database lookups while you process the request. So it's really very powerful. Of course, in this case, you have to implement all the failover logic and the load balancing logic yourself. Probably you also have to do the probing yourself. It can be done in Kamailio. It's not that easy, and it's really it's a little bit tricky, but it works quite good. So let's start with the first option, the simpler one, using the dispatcher module. There are several functions. The most used one is the DS select destination. It means like dispatcher select destination. And you tell the function which server set should be used and which algorithm it should use for the load balancing. So there you have a configuration file, usually on the hard disk, where you define the server sets. In this case, for example, we have 2 server sets, server set 1 and server set 2. And in the server set 1, we have 2 Asterisk servers. In the server set 2, we have 3 Asterisk servers. And if you make changes to this file, you just have to call the function ds-reload. For example, via a FIFO interface of the SIP proxy. Then it reloads the configuration and uses the new configuration. There are several different dispatching algorithms available. As I said already, like hash over call ID, hash over the from URI, hash over the to URI, hash over the request URI. You can use simple round robin or just random. You can use a hash over any variable you have defined within the configurations language. And you can also use weight-based distribution. So in this case, Kamailio also always counts how many calls are currently active on which server and uses the one with the which has less calls currently. Say again? No, you can only use one of these. If you use the dispatcher module like takes care of everything internally, and you only can use one of these. If you need like a combination, then you have to do it. You have to implement the dispatching algorithm manually, writing the configuration script of Kamailio. So here's a simple example how to use such a how to use the dispatcher module. The first thing I usually do is to change the timeout of the transaction module. In this case, it's set to 3,000 seconds. That means 3,000 milliseconds, so 3 seconds. Whenever the module, whenever Kamailio forwards a request and doesn't get back any response, like 180 ring or 100 trying, then it considers the forwarding to be failed. Because usually you get back a 100 trying within like 100 milliseconds, or if it's like in your local environment, you get it back within 1 millisecond. So you can also reduce this if you want faster failover. Then in the root block, as I told already, the requests will be processed. So the first thing is, of course, if a request enters Kamailio, we have to find out, okay, what is this? Is this a request from a client to an Asterisk server, or is it from an Asterisk server to the client? Because if it's to a client, we don't do load balancing. We only do load balancing if it's coming from a client and going to the Asterisk server. So in this case, there's a function, it's called dispatcher is from list. So it looks up the source IP address of the request if it's coming from one of the Asterisk servers. In this case, we do normal root processing. If not, we select destination set 1. We are using algorithm 4. That would be, in this case, round robin. Then we activate a failure route, and then we forward the request, and now we are done. So, and if the routing fails with timeout or 500 internal server error, then the failure route will be executed. And in the failure route, we call the function dispatcher next destination. That means check if there's a next destination still available, and if yes, we do the same again. We again activate the failure route and forward the request. If there is no more servers available, this function will return false, and we are done. That means the last failure code will be sent back to the client. So if we take how does it now look like with the simple round robin request, for example, a register comes in, will be forwarded to server 1. Now an invite comes in from Bob calling Alice. If we just use round robin, the next server will be used. And probably this server tells us 404 not found because Alice is not registered on this server. So you see, it might getting tricky once you activate a cluster because you have to take care of many special things which can happen. In this case, a workaround would be to use, for example, Dundee between your Asterisk servers, that every server know if a client is not registered locally, on which Asterisk server is it registered. Or a workaround would also be to not use round robin, but to use load balancing this on the from or to URI of the zip request. For example, if the register comes in, we take a look at the to URI. Okay, zip Alice at Atlanta. So we still use like load balancing of all these servers, but we make a hash over the zip URI, and then we distribute all hash values evenly over the 3 servers. Then if Bob sends a request to Alice, so for a register we take the to URI, for invite we take the request URI, which is not, of course also Alice at Atlanta. And now we get the same hash value, and as the hash values are distributed evenly over the existing zip Asterisk servers, the invite will be routed to the same server. So short summary of the dispatcher module. It's rather easy to configure it. You just use 2 or 3 functions of the module. You can define several target sets. So you can also have like a cluster of 1.4 servers or of 1.8 servers. You can use various load balancing algorithm. You have automatic probing of the servers. So it's as soon as a server will be detected as it's broken, it will not be used anymore. And if it comes back, it will automatically used again. But the disadvantage is you have no direct control to which server a request will be sent. The module decides for you. So that's in some cases that's very good. You don't have to care about it. In some cases, for example, you want to, as I said, you're introducing a new software version and want to move a certain customer, only a certain customer to this new server, a friendly customer for testing. So then you need full control. And then you cannot use the dispatcher module, but have to implement the load balancing manually. So another disclaimer or warning, as soon as you add a load balancing to your system, you have lots of cool new features available, but you changes the zip topology. Previously, you only had the zip client, the zip phone, and Asterisk, and nothing in between. So now you introduce another hop, so that, of course, new hops can always cause problems. And if you have multiple hops, you're using usually the zip feature, which is called record routing and loose routing. And there are still always clients out there which do not implement it correctly. So, and you have to, I will show you also an example where invite and subscribes must be handled differently. For example, with the record routing, if you don't use record routing, only the first invite will be sent via the load balancer, and all in-dialog requests like the acknowledge, the buy, re-invites, refers will be sent directly to the server. This is usually not what we want, because we want to have one ingress point in our network. So usually we always do record routing on the load balancer, that also the in-dialog requests always sent via the zip proxy. Now, when last time I activated the load balancer at the customer, we had a cool new feature or bug of a phone. There were linked the Cisco SBA phones, a certain firmware version. Also, record routing was activated. The phone worked fine for invites, but if it was a subscribe dialog, the record routing was ignored, and resubscriptions were always sent directly to the Asterisk server. Of course, there was a firewall which protected direct communication with the Asterisk server, so the resubscription failed. Of course, it takes then some time, like 30 seconds, or it tries 30 seconds, then it waits some time, and then it makes a new subscription, then it worked again. But every time there was a resubscription, like the busy lamp operation of the phone didn't work for 1 minute. So that was, like, of course, not nice. And it's also not that easy now to fix it fast, to go to all your customers and tell them, okay, you have to update your new firmware. So, and there's also one cool thing of Kamailio. You can do lots of message manipulation within Kamailio. And it's in this case, it was much more easy. As a quick fix, we just did a fix on the Kamailio server. And of course, we also we changed the provisioning to push a new firmware to all the buggy zip phones. But meanwhile, we had a fix on Kamailio, and it worked quite well. For example, the workaround would be here. When the subscribe dialog will be established, we change the contact header, which is usually the Asterisk server, to point to the load balancer itself. And then the load balancer knows to forward the request to which Asterisk server. So the first thing is, on the 200 OK response from the Asterisk server to the zip client, we change the contact header. We put in the IP address of the load balancer, and we added a parameter, a URI parameter, which was the original IP address. So if you do this in Kamailio, it's quite easy. The first thing is, in the reply route, if the message comes from a load balancer and it is a response to a subscribe request, then we remove the existing contact header and we add a new contact header. And in the UI, we just provide the IP address of the load balancer, and then I put in a URI parameter called PBX, for example. And $SI means Kamailio has so-called pseudo variables which are predefined. For example, every time you are using the variable $SI, this is the source IP address of the message. In this case, of course, the source IP address is the IP address of the Asterisk server. So that means we are now forwarding a contact header which points to the load balancer and has a URI parameter which contains the original IP address where the response was coming from. So in the second step, in the request processing, if a request arrives with a to tag, that means it's an in-dialog request, and it is a subscribe request, then we define the variable $DU, that means destination URI, that is the target where the request will be forwarded. And say, okay, the destination URI is zip colon, and then we extract the value of the PBX parameter from the current request URI. And then we forward the request. So it was like just adding, like here, 4 lines of code, and here 4 lines of code, adding this to the Kamailio configuration. We immediately fixed the bug in the Zipura firmware, and the busy lamp field was working fine again. Okay, time is already over, but one thing also you have to take care is, for example, with the load balancer, different requests have different behavior. A register is never creates a dialog, so every register request will be processed by the load balancing algorithm. if you take a look at the invites and subscribes, they create a dialog. And as I told already, in dialog requests usually will be loose rooted. So if it's a invite, usually after 1 or 2 hours, everybody hangs up, and the call will be new call setup will be used again using the algorithm. So it's kind of self-healing. If you have a subscribe request, and the subscribe request usually stays alive until the device reboots, you don't have any self-healing features. I want to show it here on this slide, for example. A phone sends an invite and subscribe for message waiting. It gets routed to both to server 1, everything is fine. Now this server crashes. The load balancer finds out that the server crashed. So the invite will be sent now to the new server. Probably the phone sends a resubscribe, which is loose routed to the broken server, gets back a timeout, and then it sends a new subscribe and gets routed to the new server. So now server 1 comes back, and the load balancing algorithm decides, okay, I will send now server 1 is the one for Alice. So the invite is a new request. It will be sent to server 1, and the resubscribe will be loose rooted, and it will be sent to server 3 because the dialog is still open. And so we can end up that like calls are made by one server, and the subscriptions of this client will be made on the other server. And that's bad if it's, for example, with message waiting, that maybe the message will be delivered to server 1, and server 3 doesn't know there's a message waiting. Or if it's for presends, for the shared line appearance or busy lamp fields, then also it might not work because the calls are routed via server 1, but the subscription for presence is on server 3. So there are lots of things you have to take care until you really have a full working setup again. But once you have take care of all these possibilities, then you have really a powerful component inside where you really can do lots of message manipulation and move customers from one server to the other without any service interruption. So, disclaimer again, what are the problems with Kamailio? It's really a low-level configuration. It's not like with Asterisk. If you use Asterisk, you configure a user and says in the zip.conf username, password, and in which context it will be handled. That's it. You don't even have to know that it's using zip and what is an invite request, what is a buy request. Asterisk takes care of it. Not with Kamailio. Kamailio is so powerful because you configure it really low level. You have to tell Kamailio if request is invite, then route it there. Or if it's a subscribe request, send it to somewhere else. If it's a register, then take a look at the contact header and store it locally. So it's not like with Asterisk, then if a register is received, that it's automatically stored. You have to tell him, extract the URI from the contact header and store it in the database. So it's really low-level configuration, so it's quite difficult. And in my opinion, it's impossible to make a proper configuration without the understanding of zip. So if you don't know how zip works, you're not, I'm quite sure you will fail if you, probably it will work, but it will not be secure, and that's a huge difference. So it's rather a long learning curve until you really know all the features of Kamailio. But of course you can go for consultants. There are lots of consultants available, or just go to a Kamailio course. Meanwhile, there are also Kamailio courses in Europe and the US from a few people, so that would be a good starting point. Last slide. Now we have a load balancer in there as a single ingress point. So of course this makes this component really, it must be high available, because if this component fails, everything is broken in your system. So the load balancer really needs to be a high available system. And the typical approach we see is to use the standard Linux clustering kit. So the first thing is, of course, we have one IP address usually, so we cannot have the one IP address active on several servers. We use an active standby setup. So if the main server crashes, we move the IP address to another server, and then we activate the load balancer on this server. And of course, it should be done automatically. Therefore, I usually use Pacemaker as a cluster resource manager to move the IP addresses and start the Kamailio processes. And as messaging layer, if you use Pacemaker, you can decide either use CoroSync or Heartbeat. That's probably a question of what, yeah, both work very fine. Probably take the one which is available in your favorite Linux distribution. So I hope I was not too confusing and give you a bit of an insight what you can do with Kamailio, what benefits you get, but be prepared, it's not that easy. But if you need help, I told you already, there are consultants, like you can call me anytime. And there's also, we have like made on the website of Kamailio a list of a so-called business directory. And there are several companies from US, Europe already on this list. And yeah, just ask there and I'm sure they can help you. Thanks for your attention.